Hello! In this video, we are going to prove the following theorem. Suppose A, B, and C are sets. If A is a subset of C and B is a subset of C, then A union B is a subset of C. Okay, so let's start out the proof. Let's suppose A, B, and C are sets. And so our goal now is to prove that if this is true, then this is true. So let's suppose that A is a subset of C and B is a subset of C. And now we want to prove that A union B is a subset of C. In other words, we want to show that everything in this set is also in this set. And to do that, give me an arbitrary element of this set. I'll call it X. And now we want to show that X is also an element of C. Okay, so what does it mean for X to be an element of A union B? If you recall, all that means is either X is an element of A or X is an element of B. And so now we're going to consider two cases. So really, we're going to consider the case that X is an element of A and prove that X is an element of C. And then we're going to consider the case X is an element of B, and we'll also prove that X is an element of C. So let's start with case one, where X is an element of A. But since A is a subset of C, it follows that X has to be an element of C. And we're done. We have shown that X is an element of C. So now let's move on to case two, where X is an element of B. Notice we also know that B is a subset of C. So since X is an element of B, it follows that X must also be an element of C. And so really, we've proven whichever one of these happens to be the case, X must be an element of C. So really, we can conclude that X is an element of C. So really, we started with an arbitrary element, X, in A union B. And we showed that X must also be in C. Therefore, everything in A union B is also in C. And that's exactly what we wanted to prove. And so this completes the proof. And yeah, that's pretty much the idea of how you could prove a theorem like this. So yeah, that's pretty much it for this video.